Okay, so now let's see 3 examples where we can use SOHCAHTOA, what we just learned. Oh, excuse me. Let's start off at the top. So, sine 35. Now, what does that equal? Well, we can plug that into our calculator and it equals 0.57. So, the sine button on the calculator is in the middle. Sine 35 equals 0.57. If it doesn't equal that, you are in radian mode and you have to convert it into degree mode. Make sure that you're in degree mode. So what does that mean? Well, from grade 8, we know that 0.57 is just 0.57 over 1. It's also 57 over 100. Interesting. Okay, we've been talking about right angle triangles. Let's draw a right angle triangle for both, where we have a side length. So, the second fraction, well, what do we know the definition of sine theta is? Well, we know sine theta is equal to opposite over hypotenuse from SOHCAHTOA. So, well, we have the first triangle with the first fraction. Excuse me, in the notes I did it this way, so I'm going to do it this way. So let's put this fraction here and this fraction here. So again, the definition of sine theta is opposite over hypotenuse. And if we know that the sine of 35 in both of our right angle triangles, drawing your right angles, we have an angle of 35. And what are the opposites over the hypotenuse? So the second fraction, the opposite is 57, and the hypotenuse is 100. Or the opposite is 0.57, and the hypotenuse is 1. Just using these fractions. That's what sine does. It gives you the fraction of the opposite over the hypotenuse ratio. Now, sure, this triangle off to the right is way smaller, but the ratio works no matter how big it is. That's what's cool about trigonometry. We're taking similar triangles and angles and fractions and putting them all together. So let's keep this formula, sine theta equals opposite over hypotenuse, and let's do something to solve down below. So let's make a triangle with 30 degrees and a hypotenuse of 10. Notice there's a whole bunch of other information in the diagram. It's circled. It's found information. Don't write it. What it allows you to do is go back and see your notes in the past and know what you found. So if you want to retry the problem, draw out the problem without the circled parts, retry the problem, and see if you get the same answers or whatever. Okay, so I'm going to read the English sentence from the last page. Choose the part of SOHCAHTOA that has 2 pieces of information that we have and 1 that we want. Well, sine theta is equal to opposite over hypotenuse. We have theta and we have the hypotenuse. So we obviously use sine. Now that was a coincidence because we were working on sine above and I kind of already wrote that formula. Again, choose a part of SOHCAHTOA that has 2 pieces of information that you have and 1 that you want. And if you try and fail and it doesn't work, you just obviously can't use that one. Whatever, let's substitute. So sine, now this time I have an angle of 30. So sine 30 equals opposite. I don't have the opposite. OPP or O. And the hypotenuse is 10. Put 10 on the bottom. Now we're going to do some algebra. We have a 10 on the bottom, so we want to times both sides by 10. I forgot to label my diagram. HYP, OPP, ADJ. Do that every time. Opposite is opposite. The question says solve for the opposite. Okay, so we times the sides by 10, so we're going to cross off the 10s, and then 10 times sine 30 is 5, so 5 equals opposite. Circle your answer. Put it in the diagram where it belongs. Circle your answer. Check your answer. Rewrite sine theta equals OPP over HYP. Substitute. Sine 30 equals opposite we now know is 5. Hypotenuse we now know is 10. As we learned from grade 8 equations, we type in the left-hand side into our calculator and we get 0.5. And type in the right-hand side into our calculator, we get 0.5. So we know our answer is correct. Okay, so now I'm going to shrink that stuff up a bunch. Like, obviously, if you're following the notes, just keep reading. If you're using paper, just flip it over to the next page or whatever. We're now going to do a little algebra review. Okay, so 2 equals 6 over A. Sure. Now, I do every step in the notes, but I'm going to just do it all here. Like, I rewrite it and then do a step. And then rewrite it and do a step. I'm just going to start doing stuff. So I have A on the bottom. I'm going to times both sides by A. You know what? I lied. I'm going to rewrite it once. 2 equals 6 over A. I have an A on the bottom. I want to times both sides by A. On the right-hand side, I have A over A. I can cross them off. I can clean up what I have. 2A equals 6. I can divide both sides by 2 over 2 over 2. A equals 3. Interesting. Circle my answer. Okay, so A is 3, sure. Let's see something else. Let's see 2 equals 6 over A. The same as we just did here. Now, instead of doing all that algebra, timesing both sides by A and then dividing both sides by 2, couldn't we just cross multiply and switch the A and the 2? Well, I don't know. Is that allowed? Well, A equals 3. Same answer. Absolutely. So we're going to go down the page. So I need to shrink that up a tad, either write smaller than me or use a new page. Okay, so now the question says solve for the adjacent. So now I have to find the adjacent of the diagram. So the adjacent, well, we have the hypotenuse and the opposite. So let's use tangent. So keep in mind you could use cos. Let's use tangent. Tan theta, that's T-A-N, excuse me, T-A-N theta equals, now the definition of tan, TOA, is adjacent, ADJ, over, excuse me, TOA. I'm going to write TOA. Opposite over adjacent. Now I'm going to substitute in the formula. Tan theta equals, excuse me, we have the angle, it's 30. Tan 30 equals opposite over adjacent. Now we have the opposite. It's 5 over the adjacent. So, keep in mind it would have been easier to use cos. So, now we're going to use the algebra we just learned. So instead of timesing both sides by the adjacent and dividing both sides by the tan 30, we're going to switch the adjacent. ADJ and the tan 30. Just switching them. Because we just, Big Blue, learned the algebra, how that's possible. That's called cross multiplication. Okay, so we can type into the calculator. ADJ equals 5 divided by tan 30. 8.660, whatever. So we just found the adjacent, so now we can put it up in the diagram where it belongs. 8.66, circle it. Now keep in mind, off to the right, we could have just used a squared plus b squared equals c squared. Look at the notes to find that the part B is equal to 8.66, the same as we just got. Now let's find the other angle. Well, we know one of the angles is 30. Oh my gosh, I don't even have my right angle in my triangle. Put your right angle in your triangle. Ugh. We know that there's 180 degrees in a triangle. So I'm just going to write that note, 180 degrees in a triangle. I love doing it that way. And if one of the angles is 90 and one of the angles is 30, 90 plus 30 is 120, and 180 minus 120 is 60. So the other angle is 60 degrees. But what if I don't want to use Pythag? Well, we have to use trig. And what if I don't want to use 180 degrees in a triangle, then I have to look for the other angle. So I'm actually just going to draw the triangle again, the same triangle that we've been working on. We found 8.66. We were given 10. We were given 30. We know it's a right angle. We found 5. Now, what if we want to find angle beta? Well, now the opposite and the adjacent switch. The opposite and the adjacent switch. So I'm going to shrink that up a little bit. So now, oh, again, look at that. So beside me finding, using tan, I found cos. I found using cos. And then I'm going to do what I'm going to do now. So because we had already done that example at the top, just timesing both sides, it's not included. So now let's look for cos. Finding the angle. So let's say cos, but now it's beta. We're not talking about theta anymore. Equals, the definition of cosine is ka. I'm going to write the ka again so I don't forget that. Adjacent over hypotenuse. HYP. So I can substitute cos beta equals the adjacent now from above is 5 over the hypotenuse is 10. They switched. So I've got to scroll up a little bit so you can see it, so my picture's not in the way. And then we know we find the angle from last page of notes. Beta equals cos negative 1 open bracket 5 over 10. Therefore, beta equals 60 degrees. Circle your answer. The same way we found it with the 180 degrees in a triangle. So remember, they might tell you you're allowed to use Pythag and you're allowed to use 180 degrees in a triangle, or you always have to use trig. I recommend always using trig. I recommend also solving the whole triangle, even if you're not told to. Then use a whole bunch of reverse processes like Pythag and 180 degrees in a triangle to confirm that you did it all correctly. So, in summary, we did 3 different things. Now, keep in mind, there's SOHCAHTOA, which is 3 different things. Then we have to do 3 different things for each of those 3 different things. So some people think those are 9 different things. And then if you add a few more, it gets whichever. If you understand SOHCAHTOA, big blue title at the top, SOHCAHTOA, then there's either typing into the calculator, the example that we're not even going to talk about, at the top left that I just put a big blue arrow to. Typing into the calculator, easy. Do we do 3 different examples? 1, where we times both sides by 10. 2, down below, bottom left, where we switched the thing on the top left with the thing on the bottom right using cross multiplication. Bottom right, 3, finding an angle. The exact same things that we talked about on the previous page. So you're going to see a million questions in the homework and go, oh, but you only give us one example. Well, write down SOHCAHTOA. Choose the part of SOHCAHTOA that has 2 pieces of information that you have and one that you're looking for. Do one of these 3 examples, and you're good. Be very careful about theta and then finding the other angle, because when you switch theta and, well, when you leave theta 30 and find beta 60, well then, it gets a lot more difficult because you have to switch opposite and adjacent. I forgot to, in all my diagrams, put 60. I'm going to do that in purple. 60 degrees near beta. I'm going to circle it. And in the diagram at the top left, 60. Circle it. Circle your answers. Put them back on the diagram. Circle your answers. Okay, trigonometry is a lot of fun. It allows us to solve right angle triangles. Keep in mind we get a new definition when we get to calculus 12.